Let's quickly recap where we are. You now understand that CS2's smoke system uses a unified volumetric approach where all systems read from and write to a single 3D data structure. This unified approach is what enables automatic interactivity. When a bullet changes smoke data, every system sees that change instantly. So, how does CS2 actually build this unified system? It starts with something called voxels. CS2's smoke system is built on voxels, tiny invisible cubes that fill 3D space. The word voxel comes from combining volumetric and pixel. Just like a pixel is the smallest unit of a 2D image, a voxel is the smallest unit of 3D space. Here's what makes voxels special. Each voxel is a small cube that can store information. In CS2's case, each voxel stores one simple piece of data, whether it contains smoke or not. Think of it as a tiny box that's either on, filled with smoke, or off, empty air. When you throw a smoke grenade in CS2, the game creates thousands of these voxels arranged in a massive 3D grid. Picture a checkerboard, but instead of being flat, it extends in all three directions rows, columns, and layers stacked on top of each other. This grid exists in the game world's 3D space, not on your screen. It's the invisible data structure that remembers where smoke is at every moment. Each voxel in this grid is roughly the size of a player's head, small enough to create smooth looking smoke, but large enough that the computer can track thousands of them efficiently. The entire smoke cloud area is covered by this grid. When smoke spreads, it's actually the game marking individual voxels as filled. When a bullet creates a hole, the game marks specific voxels along the bullet's path as empty. If you've played Minecraft, you've already seen voxels in action. Minecraft's world is made of visible blocks. Each block is a voxel that can be dirt, stone, wood, or air. CS2's voxels work on the same principle, but with two key differences. First, CS2's voxels are much smaller. A Minecraft block is roughly the size of a refrigerator. CS2's smoke voxels are about the size of your head. You'd need hundreds to fill the same space. Second, Minecraft shows you the individual blocks, but CS2 hides the voxel grid completely. You never see the individual cubes. The rendering system reads the voxel data and displays a smooth, realistic smoke cloud. The voxels are just the invisible data structure underneath. This voxel grid is what makes CS2's interactive smoke possible. Remember how traditional games separate visual effects from gameplay logic? They can't create bullet holes because the visual system doesn't know where bullets are, and the gameplay system can't change what you see. CS2 solves this by storing everything in the voxel grid. When a bullet travels through smoke, the game calculates which voxels the bullet passes through and marks them as empty. Because every system reads from the same grid, the changes happen everywhere simultaneously. The rendering system sees those voxels are now empty, so it displays a hole. The vision blocking system sees those voxels are empty, so players can see through that area. And the spreading system sees those voxels are empty, so it can refill them gradually. The voxel grid isn't just a visual trick, it's the single source of truth that all systems use to coordinate. To appreciate how impressive this is, consider the numbers. A single smoke grenade in CS2 creates a cloud that might be 5 meters across. With voxels sized at about 25 centimeters each, that's roughly 20 voxels in each direction. That means a single smoke cloud uses approximately 8,000 voxels. The game tracks the state of every single one of these cubes, updating them as smoke spreads, bullets punch through, grenades disperse the cloud, and the smoke gradually refills. And this happens for every smoke grenade on the map, all being calculated and rendered 60 plus times per second during gameplay. You now understand that voxels are the invisible 3D grid storing which tiny cubes contain smoke and which are empty. Next, we'll examine how the computer actually stores and accesses this massive grid of 8,000 plus cubes in memory without slowing down the game.